Evaluate the limits as n go to infinity, as I go from 1 to n, I to the fourth over n to the fifth plus I over n squared. To evaluate this easily without using the formula for the sum of the first n to the fourth power or n integers, we would need to rewrite it using the integral. We recognize that this almost, not quite, looks like the Riemann sum as I go from 1 to n of f of xi times delta x. There is no delta x here because in order to write this Riemann sum, we would need to have two factors. One is delta x and the other one is f of xi. To obtain the Riemann sum, observe that we can factor out 1 over n, and we have I to the fourth power over n to the fourth plus I over n, and this I to the fourth over n to the fourth can be rewritten as I over n to the fourth power plus I over n. And so we will make 1 over n be delta x, and this expression need to be f of xi. The function f of x that we would use conveniently in this case should be x to the fourth power plus x, so that f of I over n equals I over n to the fourth plus I over n. Also, delta x has to be b minus a over n, and we want it to be 1 over n. We would use a equals 0 and b equals 1. We see that if we use a equals 0 and b equals 1, then x sub I equals a plus I delta x. A is 0 and delta x is 1 over n, so that xi is I over n, which is what we need. And so this limit is actually the limit of the Riemann sum, which is the definite integral from a to b of f of x to the fourth plus x dx. And to evaluate this, we first find the antiderivative, x to the fifth over 5 plus x squared over 2, evaluated from 0 to 1. This is 1/5 plus 1/2 minus 0 using the fundamental theorem of calculus part 2. The common denominator is 10, so we have 2 plus 5 in the numerator. And so the answer is 7 over 10.